The JavaScript world just got hit with a 10 on a 10 maximum critical vulnerability, and it's in none other than React.js, specifically inside its server components flight protocol. Now, this is not some random package bug. React is used by millions of apps and even huge frameworks like Nest.js. And this time, the problem allows hacker to run any code they want onto your server. No login, no permission, no nothing. Basically, a hacker could send some data to your app, and React would just execute their commands on your server. So yeah, this one's really bad. But how did we get here? Let's go back to how the web used to work. In the early days, web development was simple. The server did everything. It fetched your data, ran the logic, and sent some ready-made HTML page to your browser. The browser then just showed those pages and handled a little bit of styling or interactivity through CSS and JS. Then came the single page app era, when everyone wanted to move more logic and rendering to the browser instead. This meant loading huge JavaScript bundles, and user often saw a blank screen or a loading spinner when app was just starting up. It looked fancy but wasn't great for performance or SEO. Now we are realizing that server-side rendering actually made a lot of sense. So we are moving back to the server, but in modern ways. That's where React server components came in. Thanks to Vercel, of course. They let you choose which part of your app runs on client and which part of your app runs on server by a simple use client directive on top of the file. Server components can fetch data, use backend logic, and never get sent to the browser as code. Instead, React converts the server output into special data format. This is called the flight protocol. The browser then takes that data, rebuilds your app and React tree on the client side. But the problem lives right here in how React decodes the data. The flight protocol has a bug that lets attackers send malicious data disguised as normal payload. When the server decodes it, React doesn't properly check what it is running, and attackers can slip in any command they want. That's how a normal data package turns into remote code execution, or RC, one of the scariest kind of bugs. In short, because of a bug in how React handles serialized data, a hacker could make your server run their code. Now, let us take a look at how this attack actually works. Okay, so here is my vulnerable Next.js version serving a simple hello world website. Now let us take a look at the request we need to send in order to exploit. Now the first thing first, we need to send the next action header in order for the server to invoke it as a server function. Now we have three fields here, field 0, field 1 and field 2. Field 0 is actually our attacking code, exploitation code. Field 1 reference backs to the field 0, and then field 3 is just empty to complete the syntax. Let us take a look at this. This object mimics React's internal chunk class structure. By setting the dot then reference to chunk.prototype.then, we are creating a self-referential structure. When React processes this and awaits the chunk, it's invoke the then method and then take the fake chunk as the context this. The second critical component is $B handler reference. In React's flight protocol, the $B prefix indicates the blob reference. When React processes a blob reference, it is supposed to call this function. Here's where the exploit becomes elegant. We have polluted the underscore response object with our malicious property. When the blob handler executes response.formData.get, it is actually invoking this. We have set the formData.get to the point constructor, which resolves the function constructor. The prefix contain our malicious code. When these are combined, the function constructor is invoked with our code as string argument, creating and implicitly executing a function containing arbitrary code. Let us take a look at how this works. If I copy this and paste it in Burp Suite, change the target to our actual server IP address to port 3000 and stop using HTTPS. Now we can send the request and we'll get the response back of the ID command. We not only execute the code here, but we also get the response back. Just imagine how scary is this. Any hacker can do this with any Next.js website deployed on any server around the world. Let us try executing different commands. And that's the story of one of the React's biggest vulnerabilities ever discovered, all because of how data was serialized and decoded. If you enjoyed this breakdown, hit the like button. Stay curious, stay safe, and remember, never trust the user input.